Hi all. Software-defined vehicle is quite a buzzword nowadays in the automotive world. I just wanted to explain people in simple way with respect to what software-defined vehicle is for a beginner. So this presentation is all about that. So just pause your video once and just have a look at this slide. Can you notice the difference between these two images, or can you notice the similarities between these two items which are shown in this? I'll just move on to the next slide. Maybe that will give you a better idea. So just pause the video and think about what are the primary differences between these two phones. So I hope you have your answers by now. But anyways, I'll explain. I will just give you the answer out. So the primary difference with respect to these two phones over here is the one you see on your left, which is a Nokia phone. Basically, the phone once you buy, uh, there is no you really can't do any software modifications on the phone even after you buy. But on the other phone, which is basically an iPhone or any other Android phone which we or any other smartphone which we use nowadays, the primary difference is once you take the phone out of your box, basically you can install whatever softwares which we call as applications on your phone as we like to. This flexibility is something which is not available with the older phones. That was exactly the difference in the previous slide also. So you buy any traditional car, you get the car the way it is, and you really can't modify something on top of the car after you purchase. Okay. Now that being said, we'll just move forward. Now, the building which you see on your right, it was built using some Lego blocks. So I will tell you how it is related to the phone over here. Okay. So, in a phone, basically, you will be having one camera module, you will be having one processor, and you might be having some graphics unit, and maybe some two or three other modules, maybe audio systems and all. Okay. And most of these audio systems or whatever which are basically used in this phone are some things which are kind of abstracted out. Means the hardware is a standard one and everything else is abstracted out. Or the OEM basically has control over with respect to what chips has to go in and what should be their specifications, and they have a tighter control on that. Okay. So he basically has an end-to-end control, almost end-to-end control on the hardware and software modules or the modules which are used inside this particular phone. So moving on, this is how basically this stack looks like. So you in the bottommost layer you have the hardware or the chipset. In the middleware, basically you have one OS running throughout the phone. So it is not like one OS running on one module and second OS running on second module. It will be Android or iOS or whatever on top in the middleware. And based on this OS, basically you will be having the corresponding apps which are using the sensor information or anything from this particular middleware. So this is how a traditional phone, I mean like a traditional smartphone architecture looks like. Now, let us suppose due to some reason your phone has stopped working. What do? You just hit the restart and boom, the phone works once again. Well, okay. Now think about another scenario. You're driving a car and the car is maybe at 100 kilometers per hour speed, and say the critical functionalities. I'm not talking about your infotainment system, but the critical functionalities of a car, say your steering or brakes or whatever, the most critical thing, if they stop working, what happens? You just end up in heaven. This is what will happen. Okay. So with keeping that in mind, so that is the reason why you have a lot of SL rated. So SL is basically standing for automotive safety level check, where SLD is the highest safety level where it should not kind of fail at any case. So you the acceptable failure rate, as far as I know, is 1 in 10 power 8. So that is for SLD, which is the highest rated, which basically are your airbags, which are your steering and all these things. So to non-automotive guys, so what actually it means is your airbag should work at any case, and there is the chance of them not working are next to zero. And there are quite some SL A-rated modules also, which you can see, which are not that, where you have a failure rate of maybe just more than that is also fine, not as stringent as SLD. Okay. Now that being said, there is one critical what to say issue with respect to the way the automotive domain works as of now. Okay. So that is this particular so this slide explains that. So in a typical automotive, in a typical car, basically you have around 70 ECUs. Okay, and the worst part being none of these ECUs are from one single supplier or one single OEM. Okay, so say out of this 70, almost some 15 to 20 suppliers plus OEM parts will be the players for supplying these 70 ECUs. Okay. And this is how the building will look like with respect to the Lego blocks. So red denotes one supplier, white denotes another supplier, green denotes some other supplier, you have blue. So you have a lot of players just to build one single car. Okay. So this is how the architecture looks like. So in a mobile phone, in a smartphone, basically the architecture which you see is simple, straightforward because there are not so many components or modules owned by different stakeholders. But this is not the case in an automotive domain. Okay. Now moving on. And on top of it, there is another thing which is much more problematic. So if you see over here, now let us consider a scenario where in a car you have three different ECUs. One ECU basically, or three different modules. So one module is your infotainment system. The second module is your telematic system. Telematic system basically sends the data with respect to the car and its maybe key parameters to the cloud for analytics, for data analytics kinds of functionalities. Infotainment is basically well known. It is your where you have your music, where you have your apps running in. And the third one is basically, say for example, you're taking an ECU. Okay. You're talking about an airbags ECU. So the airbags have to kick in once there is a collision of the car. Okay. Now, if you closely observe, you see that it is supplier 1, supplier 2, supplier 3. There are three suppliers who are supplying each of this module, and all these three modules talk to one another as and when needed by the CAN bus. Okay, but if you closely observe, the hardware capabilities of all these three are completely different. Okay, so now if you're talking about a telematics unit, basically you have a old generation. I'm not telling an old generation Intel, but what I'm trying to say is I'm trying to explain with respect to the capability of that particular processor. So you can think it as a single core processor, maybe with 1 GB RAM. So that is the limit of that particular telematics unit. The second one being infotainment system is basically, you have a high-end maybe quad core processor over there, and you have a full-fledged OS like Android OS, or it could be your automotive automotive grade Linux OS, or it could be anything. And on top of it, you have your App Store. Now, if you talk about your airbags issue, now this guy, he is not talking about processors at all. He is in a microcontroller level. Okay. And on top of that, if you see even the OS also, for telematics unit, you have a custom built Linux for this particular hardware only, because for you don't have the leverage of using a lot of space. So you are very much specific with respect to what should go into the OS. And basically, on top of it, you might be having a C++ code running, and you might even be having a Docker runtime running. So I will explain with respect to what Docker runtime is in further going on. Okay. Now, if you see the airbags, there is no OS at all over there, and there is only one C code which will be running for handling all these operations. Okay. Now, you have bought a car. You are using your car for the you might have spent some good amount of money for purchasing your car. So once that you have bought your car, if you see that there are some good features which are coming out in the market out there, basically you really can't simply replace your car. Reason being, a car is quite expensive. This is not the case in a phone. You buy a phone, and yeah, you feel that the camera quality of the phones which are coming in the market are really good. Maybe after 2 to 3 years, you can consider changing your phone, exchanging your phone for the new one, because the amount of money you have to spend to get a new phone is way more or less compared to amount of money you have to spend to get a new car just for the new features. Okay. So with that being said, this is the ideal scenario which you want. You want your car and you want it to be updated over a period of time via cloud, like very similar to how our phones get updated. Okay. Now, why are we talking about it now? So the reason why we are talking about it now is basically with the advent of electric vehicles out there in the market, the amount of the number of parts which are required to make an electric car are way lesser compared to a normal gasoline car. So you have some 500 less number of parts. Okay. And on top of it, there is this new architecture which is kicking in. So here we are not talking. The automotive sector is moving out from the traditional distributed architecture to zonal architecture. Okay. So what zonal architecture means is you will not have some 70 ECUs out there. You will have some 4 or 5 zones, and for each of this zone, basically you will be having some very limited nodes, and each of this node will be connected to the sensors. So the sensors could be your vehicle speed sensor, or it could be your temperature sensor, or it could be anything. Okay. So you can just pause your video and you can just have a look at this slide. Okay. Now, with that being said, so when you are talking about zones, as mentioned over here, the compute power of these zones is higher. Means we are not means we are talking about high performance computers which are handling independent zones, and these computers have the capability of running an OS or running a custom OS, and maybe handling a lot of operation compared to how it used to be few years back. Okay. So this transition of moving transition of this SDV kind of what to say SDV kind of space is, I would say, the credit will go to Tesla for pioneering this work, because these guys, when they were actually deploying their self-driving capabilities, they do know that the models will get better over a period of time, but they should have the hardware ready for handling those updated models. Okay, their machine learning models. So because of that, what they did is they have shipped the car with the hardware, which is basically an overkill for this software which was running at that point of time. But this hardware was planned in such a way that this can handle all the machine learning operations and the model updates which will come for the next 10 to 15 years or whatever it is. So they give you a hardware basically which is too much for the software with which they ship, but the idea is over a period of time the software will be this software will become complex so that the hardware can handle it. Okay. With that being said, we'll just move on. So this is how the okay. So why does automotive space does it? Okay. So traditionally, automotive space earns their revenue in two ways. One is when they sell you the car. Second one is when you come for the dealer, or yeah, when you come for the repair station, when you want your car to be repaired or whatever it is. Now they are talking about a third vertical, basically where they get a recurring source of money. So it is very similar to how we yeah, purchase something, or how we start using something and we pay a premium to get some of these features unlocked. So this basically opens up a third vertical for the automotive space. So that is why they are also interested in this particular way of doing. Yeah, they are particularly interested in SDV, software defined vehicle. Now, with that being said, there are many examples with respect to explaining what SDB is and all. I'll give you one recently popular yeah, example which has happened. So basically, what happened was the Tesla, when they shipped their cars, basically they have shipped their cars with 70 kilowatt hour battery pack, but they have locked the battery pack to 60 kilowatt per hour. Okay. And if you subscribe for their service for range extension, I think the range which they get with 60 kilowatt hour pack was somewhere around 300 miles. And with this extra 10 kWA, basically you get an extra maybe some 50 miles. I'm not very sure, but something like that. Okay. So this was their premium feature, which they unlock for people who are interested for their feature. Okay. So in Florida, a hurricane has hit, because of which it was getting tough for people to come out of that hurricane zone, because people were just short of some 30 miles or 40 miles from their locations, because of which they were not able to get in. And as it was they have their supercharge, yeah, they have their charging station network out there. But as it is a hurricane prone area, so the ideal scenario would be to simply charge your vehicle once and start your vehicle non-stop, drive your vehicle non-stop. Okay. So, keeping this in mind, what Tesla guys did is they have unlocked this extra battery capacity for all the users who are in that particular location for free. Okay. And once these guys came out of that hurricane zone to a safer zone, basically what they did is they have locked the feature once again. So this is one classic example of what a uh, over the air update is, and how it is basically supporting this. How so? Okay, so SDV is a superset in which over the air updates is a small subset of it. Okay. Now going forward, this is how the architecture of all the automotive yeah, players would be out there. Okay. So this is basically the hardware architecture. If you closely observe, the all these four platforms which you see are the same platform. Okay, you just change swap the chassis out there. You have the same hardware platform everywhere, and the hardware which they are shipping is basically a hardware which is keeping 10 years of software updates in mind, and that is how they make this hardware, and that is how they ship. Okay. So, software-defined vehicle is not a luxury for the automotive makers. It is a what to say, necessity. Reason why it is a necessity is, if not them, some other company, yeah, some other company, like another classic example for this is everyone knows that electric vehicles will work, but no one wanted to actually work on that particular thing. The reason being, all their dealers and all their yeah, repairing centers and all these things, they are structured in such a way that they service the gasoline powered cars, and if they bring in the electric vehicles also into this space, basically they will have to make significant changes throughout their supply chain. So they didn't want to get into this particular, yeah, everyone were doing gasoline engines, and yeah, so things were just working out fine for them, and why do you even need to make this change? So that was their main mindset till Tesla came. They actually transformed the entire industry, and right now, automotive are seriously considering, and I think they have already considered moving out from this gasoline space to electric space, especially in passenger vehicles. So that being said, if not one OEM, it is very sure that the other OEM will definitely go in the SDV space, and once they start going in this SDV space, the others will be bound to act, or else they cannot survive in this space. Okay, so this is another classic example, which is like the downfall of Nokia. Just because these guys were not able to embrace the change which the first iPhone, which Steve Jobs has shown in the year 2007, as they didn't embrace the change, the company was literally, yeah, sold to, from a market leader, it went to a nobody right now, and it happened in a very, very, very short time. So this is how it is. So the automotive companies also know, they know way more better than me. So obviously the transition into SDV is happening. The transition has just started. Going forward, how this is something which I think about. This is what my prediction is. The hardware on which the car is made will be abstracted out to the fundamental layer. So, what it means is there will be a standardization of the hardware. There will not be much significant difference apart from the supplier from where you are buying. The hardware abstraction will be in such a way that any the interoperability of the softwares will be there, and slowly, maybe over a period of time, the getting vehicle updates is something which will happen just like that without even we noticing it, very similar to how our phones, yeah, operate nowadays. With that being said, basically I will conclude this part of the video, and yeah, if needed I will make further videos with respect to explaining in depth with respect to what SDV is and what are the other technologies which are being used to support this particular transition. Thank you.